Okay, children. Today we are going to start with the new topic in the integration, the same chapter. We are going to learn about the trapezium rule. So initially, we'll start with that trapezium rule. Generally, we use this trapezium rule for the integration where it's kind of not possible to do it from usual integration formats, right? Let's go ahead with the basic theorem. What is related with this trapezium rule, right? For example, suppose that there is a function. It just goes like this way around. So I need to find the value of it, fx. So function fx. Suppose that I need to work out from x naught, this is the initial x value, and I need to just it for xn, right? Okay. So if I need to find the area over here, area, how can you do it? You have to integrate from x naught to xn fx. That's the usual format where we do in our previous theories. Right? So in this case, if it is not integratable or some kind of hard to do with the normal integration, we use this trapezium rule for this. But remember that trapezium rule gives you only an approximation for this. Trapezium rule is only an approximation to integration. That's what we have to understand, right? Okay. Then let's see what is the base we use to find this trapezium rule. Okay, let's see. Let's go ahead with some kind of example and try to understand it. Suppose that this function is just like this. Okay. Suppose that this is x1 and this is just like this. What you need to do is put initially we will break up into shapes like this. Commit of a shapes over here. I just split like this way around with the same gap. With the same gap, we didn't get x naught. This is x1, x2, x3, and x4. For example, suppose that I need to find this kind of question. I just shift from one graph to next graph and we will just do it. For example, there is a graph somewhere like this. Yeah, right, like this. There's a graph over here that is they have given y equals to square root of 2x plus 3. I need to find the area from 0 to 2. Suppose that you need to find the area from 0 to 2. So what I need to do is I'll just divide it into 4 stripes. The number of stripes we can decide how do we get it? We just decided it into 4 stripes. If it is divided into 4 stripes, the each value is how much? Each value is 5. So 2 has divided into 4 stripes, the gap 0 to 2, then we can say width of a strip. With 2 to 0, you can divide by number of stripes. Number of stripes 4. Then it's each turn up to 0.5. Then you can categorize this. This is 1.0, 1.52. So there are 4 stripes. Then what you need to do is initially I'll just find the areas of the respective trapezium. What do you mean by this respective trapezium? I just link these points. This one, this one, this one, and this one like this. Now you can see if you get the area A1 and A2 and A3 and A4, you can find the total integration from x0 to x1 to x4 for this question, x1 to x4, this function fx, This is approximately similar to addition of these areas. A1, A2 plus A3 plus A4. That's a fact you have to understand. So if you add up these areas, you get a approximate, because you can see the answer is not exactly perfect. Some part of a area was missing, some part here, some part is missing. Just like some areas were missing. But anyway, you can get almost similar to answer for this. For example, if you work out over here, I just find out this area over here, But if you just zoom it out, you can understand that there is a slight difference between these areas. I will just expand it. If you do the expansion, you can see there's a slight difference over here. That's a fact where we can understand. Now let's see, how do you find these areas? Then I need to find these areas. I need these y coordinates. I need these y coordinates. I just mark with a different color. I need this y coordinate. Initially, I need to find y1, y2, y3, y4, and y5. Now you can see there is a one important thing you can understand: y1, y2, y1, y2, and this is y3, and this is y4, and this is y5. So in this case, if you divide into 4 stripes, you can understand that there are 5 y values are there in the answer, right? Okay. Then if you need to find the area, so initially we know that what is the area of a trapezium, just like this. So you can just work out area of a trapezium. If I just draw trapezium somewhere like this, if this is A and if this is B, and if the perpendicular height is H, you can say the area is A plus B divided into 2 into H. That is the area. So if I need to find the area over here, so you can say this is equals to area 1. Y1 plus Y2, Y1 plus Y2 divided by 2 into, this is the width, with D into D. Plus next one is y2 plus y3 divided by 2 into d. Then the next one is y3 plus y4 divided by 2 into d. So you can say I just get this area. This height is y1, y2 divided by 2 into this side. This height is y2, y3 divided by 2 into this side. Y3, y4 divided into this side. Like that, you can work out up to y to the power 5. So you can say this is y4 plus y5 divided by 2 into d. Now you can understand this one today, right? Okay. Then you can see for all of them, half d is common. Then you can say this is y1 plus y2 plus y3 plus y4 plus y5. Sorry, just as a small error. So if we add them together, just like this, sorry, I just made a mistake. Here, this is y1. This one plus y2. Again, this y2 is there. Y2, y3, y3, y4, y4, and y5, y5. Right. So if you work out, you can understand that today half d is there, and the first y coordinate and last y coordinate repeat once, and all other coordinates it's repeat twice. y2 plus y3 plus y4. Y4, right? If you do for more number of steps, you get into more answer for that. So this is the way you can get this fact, right? Let's try to answer this question and try to understand how to do this kind of a question. Here, initially, if you want to find out the area over here, first find the coordinates. This is the way you can do this question. Get the x coordinates over here. First x coordinate is 0, 0.5, 1.0, 1.5, and 2.0. Then you can get the relative y values. How to get the y values? Substitute these coordinates into the original function. Okay, right. That's what. So if you substitute 0 here today, so what would be the answer? 2 into 0. If I put it 0 here, 2 into 0 is 0. 0 plus 3 is 3. Square root of 3. Square root of 3. That become 1.732. 1.732. If you substitute 0.5, 2 into 0.5 is 1. 1 plus 2, 3 is 4. 4 divided by 4 square root is 2 to 3. If you put 2 square root of 5, it's turn up to square root of 5. That means if I substitute 1 here, 2 into 1 is 2, 2 plus 3 is 5, square root of 5, 2.236. 2.236. Then if you substitute 1.5 over here, what do you get? 1.5 into 2 plus 3. That is square root of 6. Square root of 6 become 2.449. 2.449. Right. Okay. Then 2. If you put 2 here, square root of 7. Square root of 7. 2.646. 2.646. Then we can find, this is the way of writing this answer. Then you can say integration from 0 to 2, square root of 2x plus 3. I just let me expand and it's easier for me to write it. You can write like this, according to this formula. Half into width of a strip. Width of a strip is gap from here, but the x difference. Here, width is 0.5, 0.5, 0.5. We get in a width of getting a same width. 0.5 into, then we can find the formula. Look at this. Half here width of a strip, first y coordinate plus last y coordinate. Right. First y coordinate 1.732 plus last y coordinate 2.646 plus 2 times of addition of intermediate coordinate except first and last. 2 times of, so we can say 2.236 plus 2.449 plus 2.646. Then you get an approximated answer for this. But actually, when you're working out with this, you have to write it as approximate, because you know that this trapezium rule gives you an approximated answer for this integration. Then 0.5 into 0.5 into first y coordinate 1.732 plus 2.646 plus 2 times of 2.236 plus 2.445 plus 2.646 close bracket close. Then you get the answer as 4.758. 4.758 is the final answer for that. That's a way of doing this kind of a question. Let's try to understand this theory from another question itself. Okay. Yes. So what we need to do is, like, I'll get another example. We need to find integration from 1 to 3. 1 to 3, 1 over x squared plus 1 dx using, we will get 5 stripes. Sorry, yeah, we'll get 2 to 1, 2, so like this, we'll get 4 strips. 4 strips. This is the way of doing it. Initially, we need to divide this into the width of a strip. So we can get this like this. Width of a strip. Width. You can get upper boundary minus lower boundary. Upper boundary minus lower boundary. That's a way of getting the width. Divide by number of strips. 4. That is turn up to 0.5. This is varying, depends on the question. Okay. Then what you need to do is, then we will get the x coordinate. We start with the lower boundary 1, x. 1, then another gap of 0.5 turn up to 1.5. Then another 2.0. Then 2.5. Then 3.0. Right. Then we want to get the y values. Substitute 1 into this. 1 over 1 plus 1, 2. It's 0.5. Then we will put 1.5 over here. So 1 divided by 1.5 squared plus 1. That answer is 0.308. 0.308. Then if you put 2, 1 divided by 2 squared plus 1. That is 1 over 5, 0.2. If you put 2.5, 1 divided by 2.5 squared plus 1, I'm substituting to this equation. I'm substituting these values into this equation. Then you get 0.138. 0.138. If you put 3, 1 over 0.1 with it. Yeah. 3 squared is 9, 9 plus 1 is 10, that one. Then what you need to do it with it. Then we can write, this is the way of exactly writing the answer. Then you can write integration from 1 to 3, 1 over x squared plus 1 is approximately equals. It's a notation of approximately equals to half width of a strip. What is the width of a strip? Gap between these two or this value. The same thing you get into first y coordinate. What is the first y coordinate? 0.5 plus last y coordinate plus 2 times of intermediate coordinate. 0.308 plus 0.2 plus 0.138. Then if you work out with this, you get the approximated answer for this integration. So that is 0.5 into 0.5 into 0.5 plus 0.1 into 2 times of 0.308 plus 0.2 plus 0.138. Then you get approximated answer 0.1573. 1573. Right. Okay. Let's see whether this answer is correct. 3 to 1. 1 over squared. So the exact integration answer is there may be a small error. Let's see whether this calculation is correct. 0.25 into here 0.6 plus 2 times of 0.308 plus 0.2 plus 0.138. Sorry, this answer is I just made a mistake. This is 473. 157. It's not 1573. This value is 0.473. That is the answer for that. Right. Okay. Let's go to another question. Right. The next question is we need to find this one. The next question, next example. If you need to find integration from 1 to 2.5. 1 to 2.5 of square root of 2x minus 1 using using 6 stripes. Using 6 stripes. Then initially we need to find the width of a strip. D. Usually use the letter D. Upper boundary 2.5 minus lower boundary 1 divided by number of stripes. It's equals to how much? 1.5 divided by 0.25. So this value is 0.25. 0.25, right? Then we'll start with the x values. Starting from 1. 1.25. 1.50, 1.75, 2.0, 2.25, 2.5. So if you want to find 6 stripes, you should get 7 coordinates because when you count the number of boundaries, there should be 7 boundaries to cover up 6 stripes. 1, 2, 3, 4, 5, 6, 7. Right. For example, just like this. So this kind of it, you're going to divide into 6 stripes. 1, 2, 3, 4, 5, 6, like this. Then there are 6 stripes. 1, 2, 3, 4, 5, 6. How many boundaries are there? 1, 2, 3, 4, 5, 6, 7. Right. Then the number of y boundaries or the x coordinates would be 1 more than the number of stripes available in the question. That's a factor to understand, right? Then we can get the y coordinates with it. So straightforward, you can use this calculator to get this answer at once. You have to follow up, press mod. I just write here the steps we need to follow up. Mod. In this mod, there is a something called table in number 7. So you can put 7. Then they ask about what is fx. What is fx? For this fx, you have to replace this part of it with it. That one you can say, I'll just enter you how to do it. 2, just put, initial put square root 2 into, then you need to find x put it. How to find 2x here? Put alpha x. This is called alpha. There's a button called alpha. This is a way you can put it. Alpha, we already done this in our previous extents. Alpha x. X is coming with the comma. X minus 1. Minus 1. Not comma, actually it's a bracket. From this way you get the answer. So 2 into alpha, the bracket this much. Then you enter this function. Then alpha x minus 1. Then press equal. Then the next step you have to press equal. Then starting point. Start. What is the start? Start is 1. Press equal. Then end. Start is 1. End. End is how much? For this question, 2.5. Press equal. Then 2.5. Then they ask about step. Step. What do you call step? Step means from what kind of a gaps you need to fill up this. Step is how much today? For this question, 0.25. In the previous question, is 0.5. Right? Then put 0.25 gap, the 1 over 4. Then you get the coordinates over here. The one coordinate is 1. 1. Then 1.25 is 1.224. 1.225. 1.5 is 1.414. 1.414 is 1 point. Then the next one is 1.581. 1.581. Yeah. The next one is 1.732. 1.732. Then the next one is 1.871. 1.871. Then the next one is 2. Right. Then you can find the entire integration, approximated answer for integration. Then you can write integration from 1 to 2.5 square root of 2x minus 1 is approximately equals to half width of a strip. Width of a strip is gap between x coordinates or the value over here. The same thing. 0.25 into the first y coordinate plus the last y coordinate, first and last, plus 2 times of addition of in between coordinate except 1 and last. 225 plus 1.414 plus 1.581 plus 1.732 plus 1.871. And you can get this answer like this. So with that, you can get this answer. Let's work out and see with it. So it's turned up to 2.331. 2.331. This is a way you can do this kind of a question. So if I just minimize to make it small, so this is the way of doing this kind of question, but just to few examples. So these are the proceedings you have to follow up to get this answer. This is the theory where we need to understand about the trapezium rule. This is the base, but anyway, you have to memorize this formula. Not memorize, actually, you should know this formula. This is important, but it's in the formula booklet as well. But anyway, you have to understand how it came, and after doing the substitution, you can get the integration using method of trapezium rule. So with that, you can get this answer.